In the bone-chilling cold of northern Canada lies a secret that has been buried for 3 billion years. Not gold, not oil, but pristine diamond crystals hidden 600 meters below ancient rock forged when the earth was still burning. To reach this treasure, humans must confront a land where nature barely allows life to exist. Winter lasts 8 months, the sun appears for only a few hours each day, and brutal storms can swallow entire mining camps worth tens of millions of dollars. There are no roads leading in, no towns to shelter in, only endless white ice and colossal machines trying to drill through primordial stone. So how did humans manage to crack open the gateway to this giant treasure below? This storm-ridden story will keep you glued to the screen. Diamonds have long been a cultural symbol, not just for their stunning beauty, but for their extraordinary value. In some cases, just a few grams can be worth over $100,000. These crystals were formed more than 150 kilometers beneath the Earth's surface, where extreme pressure and heat shaped them over billions of years. And today, diamonds can even be created from the ashes of loved ones who have passed away, a deeply emotional way to honor and remember them. It wasn't until the late 20th century that this hidden treasure finally revealed itself. Ancient kimberlite pipes began to emerge beneath the frozen bedrock of northern Canada. Open-pit mines at Diavik could only reach the shallow layers of ore near the surface, while far below lay a much larger and far more treacherous kimberlite system. At that moment, the ice road became a lifeline, a 400-kilometer ice highway that exists only a few weeks each year, serving as the only route to haul machinery, fuel, and hundreds of tons of equipment into the mining site. This temporary road paved the way for Canada's clean diamond industry, now worth more than $1.6 billion. About 55 million years ago, long before ice swallowed northern Canada, this region was a warm landscape covered in ancient forests and giant ferns. Everything changed when a series of violent volcanic eruptions punched through the Earth's crust, sending columns of magma from more than 150 kilometers below rushing toward the surface. In that chaotic moment, primordial carbon was subjected to extreme heat and pressure, transforming into the first diamond crystals. As the magma cooled, it solidified into kimberlite, sealing the diamonds inside like a geological safe, locked for tens of millions of years, untouched by anything above. And of the more than 5,000 kimberlite pipes discovered on Earth, only 23 contain enough diamonds to be worth mining. They are so rare that they're almost like hidden treasure veins, created by the planet itself, deliberately concealed until humanity happened to uncover them millions of years later. Nuban Mon, Toiko the Lamfian Bangan Hon, Jamchad documentary, Hochgyonke Jam Tinka. In early 2003, Diavik entered its first commercial mining season, and the blasting charges placed beneath the frozen surface of Lac de Gras marked the moment humans finally touched a legacy the Earth had hidden for millions of years. Hundreds of drill holes, each 10 to 15 meters deep, were packed with ANFO explosives. Then the entire site fell silent for a brief second, before a deep, heavy boom tore through the air, shaking the ground and sending massive slabs of rock flying upward, exposing ancient layers as if the primordial Earth had just been dragged back to the surface. As the dust settled, 218-ton haul trucks crawled down a 25-meter-wide spiral ramp to reach the newly fractured rock. Each load brought up tens of tons of material, though most of it was nothing more than lifeless granite. What the miners truly hunted were the dark, narrow streaks of kimberlite, the only part of the formation capable of hiding diamonds once carried upward by magma from 150 kilometers below. But that was only the beginning. Once brought to the surface, kimberlite entered a harsh series of processing stages, each step stripping away another layer of mystery buried within the ore. Sometimes several tons of rock had to be crushed, washed, and sorted just to recover a single diamond no bigger than a pea, perfectly reflecting the brutal and improbable journey it endured over 55 million years beneath the Earth's surface. As the kimberlite near the surface was gradually exhausted, the hunt for diamonds had to push deeper underground, reaching directly into the heart of the kimberlite, where the most valuable crystals still lay hidden. Here, massive crushing machines were brought in, tearing huge blocks of ore into pieces small enough to process. Yet the diamonds remained untouched. Their near-perfect hardness allowed them to survive every crushing force without a single scratch. The remaining rock then moved through a series of separation stages, each stripping away more of the surrounding material and bringing the crystals closer to daylight after tens of millions of years locked in darkness. In stark contrast to the storm-blasted world above, the air underground stayed at a steady 15 degrees C. For many workers, this cramped and dim space actually felt safer and warmer than the 50 degrees C Arctic temperatures on the surface. In the deepest levels, specialized haul trucks carrying nearly 400 tons of ore rumbled through tunnels barely wide enough for a single lane. Every vehicle had to stay in constant communication with the control center to avoid collisions inside the pitch-black maze stretching for kilometers. Even though the tunnels and steel crushers could reach deep into the earth, Divik still depended on a single lifeline running across the ice road. Each winter, when the Arctic grew cold enough to freeze dozens of lakes into a sheet of glass more than a meter thick, the 400-kilometer temporary route appeared, the only gateway connecting the mine to the outside world. During those brief few weeks, nearly 7,000 trucks carrying fuel, cement, steel, and heavy equipment traveled across the ice, bringing everything needed to keep the underground operation alive in the middle of the frozen wilderness. When the 400-ton trucks emerged from the underground tunnels, the rock, freshly escaped from tens of millions of years in darkness, entered its first stage of liberation. Kimberlite isn't sent straight to the central plant. It goes to an on-site crushing station where the raw ore is screened for the first time to separate anything valuable from the useless waste rock. Inside the station, steel machines weighing tens of tons act like giant mechanical jaws, capable of pulverizing granite as hard as metal in seconds. But that power can't be used carelessly. Diamonds, despite being the hardest natural material on Earth, are incredibly brittle. A single crushing force slightly above the design threshold can shatter a crystal into dust and erase its entire geologic history. So the crushing force is tuned with near-surgical precision, strong enough to break the host rock, yet gentle enough to keep the hidden crystals intact. The ore moves through multiple stages: slow compression, rolling crushers, and vibrating screens, each stripping away another layer of shell surrounding the diamonds and bringing them closer to freedom after millions of years underground. Once the ore had been reduced in size, the material stream moved to the cleaning stage, where the last traces of mud, clay, and mineral dust were stripped from the rocks that had traveled from deep underground to the frozen surface. Inside continuously rotating trommel drums, the ore tumbled against steel walls while high-pressure water jets blasted through every crack, leaving behind bare mineral surfaces with nothing to obstruct the sorting equipment. Any particles smaller than 1 millimeter were removed immediately, as their chance of containing diamonds is virtually zero. The remaining material passed through a series of screens to sort it by size, forming a concentrated stream containing the most valuable fraction. On a sealed conveyor belt, X-ray sensors began scanning the flow. Diamonds, with their distinctive fluorescence under X-rays, flashed brightly among thousands of dull stones. In a fraction of a second, a burst of compressed air shot each diamond into a separate recovery chamber. Material that didn't trigger the X-ray sensors but still showed the right physical characteristics was sent to the gravity separation system. In a ferrosilicon slurry, ordinary rock floated away, while the denser fraction, where many hidden crystals still remained, was held back. When the final concentrate was separated, only the hardest, most durable minerals were left, and among them, the diamonds finally began to appear. The final stream of material leaving the recovery systems moves directly into the sorting room, where the crystals, newly freed from rock after tens of millions of years, are examined by human eyes for the very first time. On color-calibrated light tables, each rough diamond is spread out and rotated under magnification to reveal its natural structure. Size, hue, clarity, crystal shape. Every detail is recorded with precision. 3D scanners and optical tools help generate models, But the final judgment still comes from the experts, who can look at a slightly off-angle reflection or a hairline fracture and instantly know the real value hidden inside the stone. From this stage, the diamonds split into two distinct paths: stones that are clean, stable in structure, and large enough or sent for jewelry cutting. The rest, irregular, small, or heavily included, are designated for industrial use, destined for ultra-hard cutting tools, drill bits, and wear-resistant components. The stones selected for commercial grading undergo deeper analysis to determine their optimal cutting plan, designed to maximize brilliance, clarity, and the economic potential locked within each crystal. Each diamond enters the cutting planning stage like its own personal surgery. The crystal's natural shape is scanned into a 3D model, revealing every facet, inclusion, and potential fracture. From that map, specialists begin calculating which angles will create the strongest reflections, which faces should be preserved, and which areas must be sacrificed to achieve a higher overall value. Some crystals are best split into several smaller stones, allowing the combined value to exceed that of keeping the diamond whole. Others, and especially the rare ones with exceptional clarity, are left intact to preserve their full shape for special designs. Every decision is measured down to the millimeter, because a single wrong choice can erase a significant portion of the stone's value. Once the cutting plan is finalized from the 3D model, the rough diamond moves into one of the most delicate stages, a precise blend of advanced technology and human craftsmanship. From this point on, every decision can change the stone's value entirely, preserve more weight or maximize brilliance, minimize visible inclusions, or aim for a rare, distinctive shape. The process begins by opening the stone with a high-powered laser. The beam is as thin as a hair, precise enough to separate the diamond along its natural cleavage lines without causing the fractures to spread. Once the crystal is divided into workable sections, the polishers take over. Using a metal cutting wheel coated with diamond powder, the only material hard enough to shape its own kind, they gradually form the first facets. The wheel turns slowly, and the pressure is controlled by the craftsman's experience, shaping each surface to capture and reflect light at the strongest possible angles. Depending on complexity, a single diamond can take weeks or even more than a month to complete. Facet by facet, windows of light appear until the entire stone reaches a perfect balance of shape, clarity, and brilliance, the very soul of every finished diamond. Once the facets have reached the desired sharpness and balance of light, the diamond enters the grading room, where its beauty is no longer judged by opinion, but by the strictest standards in the gem industry. Under specialized lighting and powerful microscopes, experts examine every tiny detail: color grade, clarity, carat weight, crystal structure, and even the natural traces left from its formation tens of millions of years ago. All measurements are carefully recorded before the stone receives an ultra-small laser inscription on its girdle, a permanent signature almost invisible to the naked eye, yet precise enough to track the diamond's identity anywhere in the world. When the grading process is complete, reputable organizations such as GIA or IGI issue a technical certificate describing the stone's characteristics with absolute precision. This document serves as the diamond's passport, ensuring that its quality and value can be verified with complete transparency by anyone who owns it. Leaving the grading room with its full passport and identification code, the diamond enters the crafting stage, where a billion-year-old mineral is transformed into a symbolic piece of jewelry. In the workshops of master jewelers, each stone is placed on the bench like raw material waiting to be awakened. Artisans consider its proportions, cut, and the metal that will hold it, then carefully shape each prong and every tiny facet to maximize its brilliance. In their hands, the rough diamond becomes a ring, a necklace, a pair of earrings, or a high-end creation destined for limited collections. Once the crafting is complete, many stones become the centerpiece of international auctions, where beauty and rarity are weighed alongside their collectible value. Others enter the world of fine jewelry, carrying special meaning when set into engagement rings. where their light holds a promise far greater than their small size might suggest. From layers of ancient rock buried hundreds of meters below ground to the bright lights of jewelry showcases, every diamond carries a journey longer than human history itself. It is a story shaped by ancient volcanoes, Arctic ice, modern technology, and the hands of skilled artisans, all converging to awaken a crystal that has slept for millions of years. With every polished facet, the diamond continues writing its destiny in the hands of whoever owns it. If the journey of bringing these hidden crystals into the light fascinated you, don't forget to like and follow Mandarin Tech for more incredible stories of engineering and craftsmanship.